What if you could deliver a fully functional, intelligent command center to the middle of nowhere? Basically, like ordering a package. Well, today, we're digging into a piece of technology that does pretty much just that. It's designed to build permanent infrastructure in some of the world's most challenging places. But seriously, think about it for a second. Let's say you need to set up a really sophisticated operation. You need power, you need data processing, a climate-controlled workspace, and you're completely off-grid. That is a logistical nightmare. It's always been incredibly slow, wildly expensive, and just full of delays.
So the answer is to just change the whole game. Instead of thinking about construction, you think about logistics. And this image just nails it. The entire core of your operation arrives on a flatbed truck, looking less like a building and more like a high-value vault being delivered right to the frontier.
Okay, so let's really break down that central problem. Why has the friction of the frontier, as they call it, always made putting up modern permanent operations so unbelievably hard? Let's get into what it really takes to overcome that.
This gets right to the heart of the whole philosophy. This isn't about temporary stuff, like tents or trailers. The entire goal here is to create a permanent anchor, a real foothold that establishes a lasting, sovereign presence from the very moment it hits the ground.
So what is this thing, officially? It's the RIOS Pilot Standard. And it's basically a modular unit that mashes up a micro data center with a field office, all packed inside a standard 10-foot container. The words to remember here are persistence, stability, and human habitability. This thing is designed to be a permanent civilization anchor.
So how does it actually do all this? Let's go inside the command center and deconstruct the three core systems that make it a totally self-contained base camp.
First up is the shell. Think of this as the armor that protects the whole system from the elements. We're talking scorching sun, driving winds, you name it. It's the physical chassis, and it's built for pure resilience.
And here you see that protection in action. Just imagine a brutal 120-degree day outside. But inside, the high-tech command center stays at a stable, cool 68 degrees. This isn't just some insulation. This is active climate control, which is absolutely crucial for protecting both the sensitive electronics and, of course, the people inside.
The details here really show you how it's done. It starts life as a standard shipping container, but it's heavily modified. It's packed with R25 spray foam. That is some serious heavy-duty insulation, and it's sealed up with a biometric steel door for security. And, super importantly, it meets OSHA regulations for a conditioned workspace. That's a total game changer for keeping your crew safe and productive on-site.
All right, next is the second core system, the grid. And the key word here is sovereign. This unit generates, it stores, and it manages its own power. It's completely independent of any external utility, 24/7, all year round. And this is the heart of that sovereignty, a massive 20 kilowatt-hour server-grade battery bank. Now, this is not some small backup battery. This is enough power to run everything, the servers, the AI, even the air conditioning, through 3 full days of clouds and no sun. That's the kind of redundancy you absolutely need for mission-critical operations.
And the specs here are really impressive. It generates 4.4 kilowatts of solar power, partly from these really clever slide-out wings. It stores that massive 20 kilowatt hours, and its industrial inverter can push out 12 kilowatts of peak power. That's enough to run heavy external equipment like welders or water pumps right from the hub itself.
The final piece of the puzzle is the brain. This is the intelligence core, and the most important concept here is always on. The AI isn't just running a few tasks here and there, it's running continuously, at full throttle.
And this is what's running the show. Forget about a desktop computer. This is a ruggedized enterprise-grade server. It's got an Intel Xeon CPU for super reliable processing and an NVIDIA A2 GPU, which is a powerhouse for handling constant, high-throttle AI workloads without even breaking a sweat.
So what can this brain actually do? Well, it can create a digital twin of the entire site. It can monitor over 50 security cameras at the same time, analyze soil data in real time for farming. It can even host a local intranet, and that means things like training wikis and medical records are always available on site, even if the internet goes down. And get this, that telescoping mask gives it an incredible 8-mile range for connecting to remote sensors.
Okay, so we've seen what the unit is. Now let's look at what it does. How does it turn a simple patch of dirt into a fully operational, intelligent hub?
Here we go.
A perfect real-world example. The unit is deployed as the command center for a 50-acre agricultural project. From this one single container, it's managing all the critical infrastructure, the water pumps, the soil sensors, everything that keeps the whole operation running.
And this visualizes the data flow perfectly. You've got information from sensors all across the field constantly flowing into the hub to be processed. The hub's brain then sends commands back out, automating equipment like irrigation valves. It's a complete self-contained loop. It can sense, think, and then act.
And its uses go way beyond just agriculture. I mean, imagine this as a rural medical clinic, keeping patient records secure and local. Or the very first building on a construction site, the site manager's HQ. It could be a security outpost running AI-powered surveillance, or a data hub where field teams can offload drone footage for processing. The possibilities are just huge.
Okay, let's shift gears and talk about the money side of things. The whole idea here is to stop thinking about this as a construction cost and start seeing it as a new class of strategic capital asset. This comparison chart just makes the value proposition crystal clear. I mean, look at the alternatives. A solar trailer gives you some power, yeah, but it's basic, with no climate control or compute. A modular office gives you space, but it's really just an empty shell that needs a grid connection for power and AC. The RIOS Pilot Standard is the only one that integrates powerful compute, server-grade power, and active cooling into a single sovereign hub. It's really in a category all its own.
So what's the price tag? The manufacturer's suggested retail price is $78,500. But, that number doesn't really mean a whole lot without some context.
And here is that context. To build a traditional concrete block office and server room in a remote area, you're looking at well over $100,000. And it'll take 4 months, probably more. And once it's built, it's an immovable liability. The RIOS unit costs less, can be delivered in 6 to 8 weeks, and this is key. It's a depreciable capital asset that you can move to the next site or even resell when the project is over.
So we'll end with this question. It really reframes the whole challenge of starting a remote project. What new possibilities open up when your very first step isn't about excavation and construction, but about deploying a complete, intelligent, and sovereign hub on day one?